Next, we move on to model building and evaluation. So I did from sklearn linear model import linear regression, from sklearn ensemble import random forest regression and gradient boosting regression, and from sklearn metrics import mean squared error and R squared score. So define evaluation model. Parentheses model x train x test y train y test parentheses. So this line of code, basically what it does, it creates like a reusable function that takes in machine learning model and the data splits as inputs. Next we do model.fit x train and y train. Basically it trains the model by finding like the patterns between the features, which is the x train, and the house prices, which is y train. Then we move on. Y train predict is equal to model predict x train, and then y test predict is equal to model dot predict x test. Basically, the first line basically generates the price prediction on the same data set used for like the training one, and then the second line basically generates the price prediction on like a new unseen test data. Basically, these training predictions help us assess how well the model fits the data I learned from. Then we move on to train RMSC is equal to NP square root mean squared error parentheses y train predict test RMSC is equal to NP square root mean square error parentheses y test predict parentheses. What these lines of code does is basically calculates the root mean standard error for both the training and the testing sets. Then we do train RQ is equal to RQ score parentheses y train predict. Then test R squared is equal to R squared score y test predict. Basically this calculates the R squared, which is like the coefficient of determination for both of the sets, as R squared basically represents the proportion of like the price variance. Then we print the training RMSC, the testing RSMC, the training R squared, and the testing R squared. Then we do return model y test predict. Basically this returns both like the training model and its testing predictions. Next, we move on to comparing the models with different scaling techniques. So models is equal to parentheses linear regression is equal to linear regression, random forest is equal to random forest regressor, and estimates is equal to 100, random state is 42, and gradient boosting is equal to gradient boosting regressor, and estimator is equal to 100, and random state is equal to 42. Basically what this line of code does is it basically creates like a dictionary containing like the three different machine learning algorithms with their configurations as over here. Next, we move on to for name model in models.item, print backslash n, parentheses dash times 50, backslash n, the name, backslash n, times the dash times 50, then is equal to the blank y predict is equal to elevate model, evaluate equal to evaluate model x train standard deviation, x test standard deviation, y train, and y test. Basically what this line of code does is basically iterates through each of the model, displays its names over here, and then it evaluates using like the function we defined over here earlier. Then we go on to plt.figure figure is equal to fig size 28 to 6, and then all the way to plt.show. Basically what this line of code does, it basically creates like a scatter plot of the actual versus the predicted house prices for each of the models over here. So yeah, here's the scatter plot for the actual versus predicted price for the linear regression. Training RMSC is equal to 974,861. Training test is RSM is equal to 1.3 million. Training R squared is equal to 0.69. Testing R squared is equal to 0.65. Here's the scatter plot, as majority of the dot are like scattered along the diagonal line, however with few exceptions. Then we moved on to random forest. Random forest training RMSE is a base 400k,000. Testing RSME is equal to 1.4 million. Training R squared is equal to 0.94. Testing R squared is equal to 0.60. Here's the scatter plot for the actual versus predicted prices for random forest. As so majority of the points are like scattered along the the diagonal line. However, there are a few exceptions over here. Then we move on to gradient boosting. So training RSME is equal to 565,000. Training RSM is equal to 1.3 million. Then the training R squared is equal to 0.889, and the testing one is 0.63. And here's the scatter plot for the actual versus predicted prices for gradient boosting, as majority of the dots are like along the gradient line, and as said before, there are a few exceptions. So basically, overall, these have like similar like paths. However, there seems to be like a large gap between like the training and the testing performance for random forest and R squared, for like especially training R squared versus testing R squared, as this has a higher number as compared to this one. Basically, this is indicating like significant like an overfitting to the data. So yeah. So here's the entire project. Thank you for listening and watching. So yeah, thank you.